Hello students, in this class we discuss the laws of radioactivity. Okay, in previous class we discussed about the various properties of alpha, beta and gamma radiations and about the Becquerel's theory of radiation. Okay. So, in this class we discuss about the laws of radioactivity and how can we represent the radioactive process in mathematical form. Okay. And if we observe the laws of radioactivity, then what we find? Generally, if we move towards the definition, what we get? A radioactivity is a spontaneous process in which there is always emission of some penetrating particles or like emission of some penetrating particles like alpha, beta and gamma. Okay, and the process of radioactivity does not depends upon the external conditions like temperature, pressure and any other chemical conditions. Okay, third things, if we observe, the process of disintegration is a random process and which atom will disintegrate first, it's just a matter of chance. Okay. Third things, from the Becquerel theory, what we find, when there is an emission of alpha particle from any nucleus, then the obtained daughter nucleus has its mass number less by 4 unit and its atomic number is less by 2 unit. Okay. So, emission of alpha causes the daughter nucleus or causes the any nucleus whose mass number is reduced by 4 unit and atomic number is reduced by 2 unit. Okay. Next thing, that is emission of beta. Okay. From the emission of beta, what we find? From the emission of beta, the daughter nucleus which is obtained has the mass number remains unchanged and its atomic number is increases by 1 unit. Okay. Then about the gamma radiation. When any nucleus emits the gamma radiation, then it jumps from any excited state to ground state. Okay. And last thing is about the process of radioactive disintegration. The process of radioactive disintegration is a continuous process and in that continuous process the rate of disintegration is always depends upon the number of atom remains undecayed at that time. Okay. Again I repeat, that is most important. The rate of disintegration, or so we can say radioactive, is a spontaneous process in which the rate of disintegration depends upon the number of nuclei or number of atoms present at that instant. Okay. Let us take in more clear form. Suppose we consider there are n0 number of atoms. N0 is the total number of atoms, at initial time. That means we can say at t equals to 0. Okay. Suppose we consider any nuclei. Okay. Any nuclei has n0 number of atoms present at initial time, that is t equals to 0. Okay. And suppose we consider there are dn number of atoms, that is dn is the number of atoms decay or number of atoms disintegrate in time dt. Okay. So, as dn number of atom disintegrate in time dt, so here we can say dn by dt, that is rate of disintegration, or simply we can say that is decay rate, or in some book it is written as activity. Okay. Suppose dN by dt is the rate of disintegration. Rate of disintegration means we can say number of atoms decay per unit time. Okay, that is called rate of disintegration. So that's why we taken dN number of atom disintegrate in time dt. So rate of disintegration is dN by dt. Number of atoms disintegrate in 1 second. Okay. So another thing, suppose I take N is the number of atoms present at any time t when we start measurement. Okay, that means we can say a heavy nuclei continuously radiate or a heavy nuclei continuously emitted alpha, beta and gamma, and from n0 number of atoms there is a continuous radiation, and when we start measuring at any time of measurement, any time t, the number of atoms remain in that sample will be n. Okay, so at the time of observation n is the number of atom present. Okay, and we take the time of measurement as t. Okay, and we find the decay rate, that means rate of disintegration at any instant of time t depends upon the number of sample or number of atoms remains at that time. Okay, that means we can say as per law of radioactivity, the rate of disintegration, okay, at any instant of time depends upon the number of atoms present at that instant, and there is a negative sign during this observation. What is the significance of negative sign? The significance of negative sign is that there is a continuously decrease of the atoms as the time proceeds. Okay, that means when we proceeds our time, the number of atoms from initial value continuously decreases because of continuous emission of alpha, beta and gamma. Okay, so we can say the rate of disintegration, okay, the rate of disintegration is directly proportional to the number of samples present at that instant. Okay, and the physical significance of negative sign, we can say negative sign represent number of atoms decreases with increase of time, with increase of time. Okay, understand? That means as we proceed, as the disintegration or decay rate proceeds, number of atoms from the initial value gradually decreases. Okay, so that is negative sign indicates there is a decrease of number of samples from that radioactive nuclei. That means we can suppose I take a simple example. At initial stage there are 1000 number of samples. Okay, and in pause 1 second it emits 10 nuclei. Okay, 10 number of atoms it emits. Okay, that means first second the emission will be 10, so remaining 990. Okay, in second there will be emission of another 10, so the from 990 that will be 980, and in third second again there is a 10 number of emission, so that is 970. So that will be decrease as the time increase, the value continuously decreases. Okay, so that's why we represent a negative sign. Okay, so now remove the proportionality constant, so we can say dN by dt equals to some constant lambda into n. Okay, and the lambda is called decay constant. Okay, or simply that is disintegration constant, decay constant or disintegration constant. Okay, so dN by dt equals to minus lambda n. Lambda is a proportionality constant, and that proportionality constant is also known as decay constant or disintegration constant. Okay, So now dn by n equals to minus lambda dt. Okay, and if we integrate on both sides, what we get? Suppose we integrate from both sides, integrating both sides. Okay, so integration dn by n equal to minus integration lambda dt. So dn by n, that is dx by x, that is log x with base e. Okay, so simply we can say, so log n with base e equals to minus lambda is a constant, so integration of dt is t plus some integration constant, that c is called integration constant. Okay, so now take one consideration. Okay, suppose we take at initial time. At initial time, what is the number of sample? We take at t equals to 0, number of sample is n0. Okay, so we can say at initial time, that is t equal to 0, number of atoms n equals to n0, that is we move toward the initial phase of disintegration. Okay, so if we replace this condition in equation 1, what we find? Log n0 equals to c. Okay, so that integration constant is replaced by log n0. Okay, so if you replace this value in equation 1, so what we find? Log n with base e equals to minus lambda t plus log n naught with base e. Okay, so that implies to log n base e minus log n naught base e equals to minus lambda t. Okay, so that implies to, you can say, so if you remove the logarithmic by anti-logarithmic value, so another you can change here, n by n naught log a minus log b, that is log a by b, so that is minus lambda t. So if you take the anti-log on both sides, so n by n naught equals to e to the power exponential minus lambda t. So what we get? N equals to n naught e to the power minus lambda t. Okay, so that is called disintegration equation, or we can say radioactive decay law. Radioactive decay law. Okay, so that is n equals to n naught e to the power minus lambda t. N naught, that is number of sample at initial time, n, that is number of sample at any instant of time t, lambda is the decay constant or disintegration constant. So that equation is known as law of radioactivity or radioactive decay law. Okay, and if we plot the variation of number of sample with the time, okay, so what we find? Suppose we take the variation of number of samples with the time. Okay, so there is a variation of, suppose in x axis we are taking the time t, and in y axis we represent the number of sample n. Okay, so how the variation, as we discussed as the time proceeds, number of sample continuously decreases, and this one is the place of t equals to 0. Okay, at t equals to 0, that means origin, at t equals to 0, suppose number of sample is n0, and as the time proceeds, the number of atoms or number of samples from the nucleus continuously decreases, and the decay rate is exponential. Okay, so you can say the number of sample from the nucleus exponentially decay. Okay, and if we observe the exponential decay variation, we find this will be the variation of number of sample with time. As the time proceeds, number of sample continuously decreases, and when the number of samples totally or completely comes to 0, when we replace here infinity. Okay, if we take t equals to infinity, that is at infinite time, the number of sample n equal to n naught e to the power minus infinity. So n equal to e to the power minus infinity is 0, so number of sample will be 0. So this graph meet the x axis at t equal to infinity. Okay, so this will represent the variation of time with the number of sample decayed. Okay, understand what is decay law? So decay law is n equals to n naught e to the power minus lambda t. So this one is very important. Okay, this will help you for the problem calculation and other calculation value. Okay, n is the number of sample at any instant of time, n0 is the number of sample at initial time t equals to 0, and lambda is the decay constant. Okay, and number of sample decay depends upon exponential value of the time. Okay, that means we can, the number of sample exponentially decreases with increase of time. Understand? Thank you.